Welcome back everyone, Patrick here, moving on to the next question. So what we have to do in this video, we got to verify that these 3 points, -7, -3, 0 and 4, and then -4 and 6, lie on a circle that has a center at -4 and 1. Then once we verified that, we have to then find the equation of the circle. So this question's not too bad. There's going to be some algebra, but let me first show you just visually how it works. So we have a circle and we're told that it has a center at -4 and 1, like that. And then what's happening is that we're given 3 points and we have to verify that the 3 points lie on the circle. So what I'm going to do is I'm actually just going to draw 3 random points. Now if you draw this on a Cartesian plane, it's not necessarily going to take this kind of shape. Like, for example, this point, -7, -3 on a Cartesian plane, it's actually going to be below this point, right? Because the y value is smaller than 1. But I'm just drawing this as a rough drawing just to have a reference as we go. You don't necessarily have to make a diagram, but I kind of just want to show you the intuition of what we're doing. So the question is, how can we verify that these 3 points are on this circle that has a center -4 and 1, right? That all 3 are on the same circle. Because if you think about it, there's an infinite amount of circles we can make with this center. We can make a circle here, 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 right? We can keep going an infinite amount of ways. But these points, all 3 points, they have to lie on one circle. And so that's what we have to verify. So question is, how do we do that? Well, if you think about it, this is the center of the circle. What's the distance from the center of any circle to any point on the border or the outside of the circle? Well, that distance is always going to be the same. It's always just going to be the radius, right? So what we can do is we can find the distance from the center to each of these points, and if the distance is the same to each of the points, then we know that that represents the radius, and so those 3 points would be on that same circle with that same radius. Okay, so that's all we have to do. So let's, I'll label the center of the circle as M, right? Maybe to symbolize middle, and then I'll have A, B, and then C, like that. So let's first find the length or the distance from this point to this point, right? The length of AM. Now, the length formula, square root of, it doesn't matter if you put the x's or y's first. I'll put the x's since we usually do that. Like that, right? That's the formula for the length between 2 points. So what I'll do is the M I'll keep as x1, y1. It's going to be the same for all of them. And then for this first calculation, let's label A as x2, y2. So we'd end up with x2, which is -7, minus x1, which is -4. So just be careful with the bracket there. That's going to be squared, plus y2, which is -3, minus y1, which is just 1. That's going to be squared. So we'd end up with, this is going to be -7 plus 4. That's going to be squared, plus -4. That's going to be squared. So this would end up being -7 plus 4 gives us -3. That's going to be 16. So we'd end up with 9 plus 16, like that, which would give us root 25, which is just equal to 5. So the distance here, we verified it's 5. So that's the radius of the circle that we are working with. Okay, so now we just have to verify that the other points have that same distance to that center of the circle. So now let's find the distance from B to M right here. And so M we already have labeled as x1 and y1. So really all we got to change is the x2 and then the y2. So this would be x1, or sorry, x2, y2, like that. So we'd have 0 over here, the y2 would be 4, right? And then the x1, the y1 are the same thing. So this would end up being 0 plus 4, right? The two negatives turn into a positive, so we'd have positive 4 squared plus 3 squared. What does that give us? 16 plus 9 root 25, which is 5. So this here is also 5. And then we have one more point to verify. Let's find the distance here. So we'll label this as x2, y2, right? So now we're finding the length of CM. So we'd end up with negative 4, right? Yeah, and then 6 for the y2, like that. So what would we end up here with? Well, we would have negative 4 plus 4, that's going to be squared, and then we'll have 5 squared. So this would end up being 0 squared plus 25. So we'd end up with root 25, which would give us 5, like that. Okay, so all three have the same distance. And so because all three have that same distance of 5, that's enough to verify that those 3 points lie on the same circle that has a center at negative 4 and 1. That's what you have to do if they ask you to verify. Okay, find those lengths. Now, what they're asking is to find the equation of the circle. Now, if, just in general, if a circle has a center at H and K, right, doesn't matter what letters you use here, usually you'll see H and K being used, those are popular. If a circle is centered here, the equation of it is going to be x minus h squared plus y minus k squared equals the radius squared. Well, we already know this is the h and the k, right? That's the center. So we'd end up with x minus negative 4, be careful with the brackets over here, plus y minus 1 squared. And then there's 2 ways to go about this to get the equation. We already know what the radius is, so we could just plug in a 5 for the radius, right? So this would end up being x plus 4 squared plus y minus 1 squared equals 25. Okay, so that's the equation right there. Another way you could do it is instead of plugging the radius directly, I feel like that's the easiest way if we already calculated the radius, but another way you can do it is this left side, the work for the left side would be the same. Okay, so you'd end up with the left side being x plus 4 squared plus y minus 1 squared equals r squared. And then what you could do to get that r squared is you can actually take any of these points that are on the circle and plug them in for x and y. So for example, let's say we took negative 7, negative 3. Notice we'll have negative 7 plus 4 squared plus negative 3 squared. And then all you have to do is just do the algebra here. Negative 7 plus 4 would give us negative 3 squared would give us 9, plus negative 3 minus 1 is negative 4 to the power 2 gives us 16. And so we end up getting 25 for that r squared. Okay, and then you could just take that value for r squared and then just plug it in there, right, to get that same thing. Okay, and then for that x and y there, you could plug in 0, 4, negative 4, and 6. You're going to end up getting 25 each time. Doesn't matter which one you use. Again, so that's a kind of a longer way to do it. It's not my preferred method. Once I have the radius, it's easiest to just plug it in, and then you get that right side being 25. Right, whichever way you do it though, that right there is the equation of that circle.